Hi guys, so we're going to just review functions real quick. We're going to review some things that we've already talked about, and then I'm going to add in at the end some new ideas. So this is your sheet. It's a little bit different than other notes, and I think for the most part it does go left to right. So here's just the title, and then over here are the objectives, but really we just want to go ahead and look at the slide that says X and Y intercepts. Okay, so the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So, right here, we have lines that are all pointing to those spots. So these are our x-intercepts. Okay? And then the y-intercept would be right there where we're crossing the y-axis. But remember, x-intercepts are also called roots or zeros or solutions. Okay? So that's pretty easy. So then the next slide, and I tried to put stars or blanks for everything you need to fill in. The next slide goes through and helps us understand how to find intercepts if you don't have a graph. So it says the x-intercept is a point in the equation where the y value is 0. So that means that since the y value is 0, right here, that means y equals 0. So to find the x-intercepts, we've put in 0 for y. So if this is the equation, 2x squared plus 4y squared equals 16, 25x squared plus 4y squared equals 16. What we do is we put a 0 in for that y. Okay, and we solve for x. Well, this 0 makes this entire term cancel out because 0 squared is 0, 0 times anything is 0. So you just ignore the term that had the y in there. We have 25x squared equals 16. Divide both sides by 25. We get x squared equals 16 over 25. And then remember, the opposite of squaring is square rooting. So in order to finish solving this, we would square root both sides. And when you square root both sides, you really can just square root the top and the bottom. So you get x equals the square root of 16, which is 4, and the square root of 25, which is 5. And remember, whenever you square root, you get two answers, or because it's x squared, you have two intercepts, so it's plus or minus. So it crosses at positive 4/5 and negative 4/5, okay? All right, so then, let's see what else we have. Alright, so to finish out that idea, we do the opposite when we're looking for a y-intercept graphically. Algebraically with an equation. Okay, so to find the y-intercept, it's where the x value is 0. So we put in 0 for x instead, and then we solve it in that case. So we go back to the same equation, 25x squared plus 4y squared equals 16. But since we're looking for the y-intercept, that means x is 0. So 25 times 0 squared plus 4y squared equals 16. 0 would make that whole term cancel out. So really just focus on the y term. 4y squared equals 16. Divide both sides by 4. Y squared equals 4. The opposite of squaring, again, is square rooting. And this square rooting is a little bit easier. So y equals, square root of 4 is 2, but we need two answers. Whenever we square root, we have the positive version and the negative version. So it's plus or minus 2. Okay? So then this shape is also crossing the y-axis at positive 2 and at negative 2. of us have done increasing and decreasing. So we are just going to fill in what this is talking about with increasing and decreasing. Okay, a function f is increasing on an interval if as x increases, f of x increases. So as we're going off to the right, it's also going up. Increasing means as you go from left to right, it's going up, okay? A function f is decreasing. So decreasing means going down. On an interval, if as x increases, then the function decreases. So as you go from left to right, as you're getting larger on your x-axis, it's going down, okay? So it's just like reading a book. As you go from left to right, if it's going up, that's increasing. If it's going down, that's decreasing. So it just looks like this and that, okay? A function is constant on an interval if as x increases, then the function f of x remains the same. Okay, so that means as you're going from left to right, it's not going up and it's not going down, it's just staying straight. Okay, so that would look something like that. That's constant. It's not going up or going down, okay? All right, so the best way to determine increasing and decreasing is to find the turning point and then just go left to right like we've done in the past. So in this case, the turning point or the vertex is 1.5 and negative 2. So as we go from left to right, as we come from negative infinity off to positive infinity, okay, it is on this side, it's going down. So that is decreasing. So since we're coming from the left and we're hitting that turning point, it is going down. It's decreasing from negative infinity until our x value. Remember, we're looking at the x-axis. We're using like the x-axis like a number line. So you don't care about the y value. You only care about the x value. So it's going down. So the function is decreasing in the interval negative infinity to 1.5. And then since 1.5 is where it turns, then that means it's going the opposite direction usually. So that means it's now increasing, it's now going up. So it starts at 1.5 where it goes up, but then it goes up forever, pardon me. So it goes off into infinity, positive infinity. Okay? So decreasing is where it's going down, increasing is where it's going up. And in the intervals from negative infinity, this is the turning point. So if it helps, you can kind of think of that as just kind of, it separates it into two sections. This section is decreasing, that section is increasing, okay? All right, so we do it again for this one, except in this case, there are two turning points. Again, we start from the left, negative infinity. We'll go off to the right, positive infinity. The turning points are here, which is negative 1, 2, it looks like. And here's another turning point, positive 1, negative 2. Okay? And again, if it helps to kind of use those turning points to break it into sections, that's fine, however that helps. And remember, you don't look at the y values, we just look at the x values. We're using x like a number line. Okay, so from left to right, so this section is increasing because it's going up from the left off to the right. This section is also increasing because it's going up from the left to the right. Okay, so find the intervals over which the interval is increasing, decreasing, and constant. So increasing, there are two intervals. So from negative infinity, and then it stops here, so that's -1. In union, starts here again at 1, and then it goes off forever into positive infinity. Okay, let me make sure you can see that. All right. And then it also says decreasing, so it is decreasing. I wish I had a better marker, but okay, it's decreasing right here. It's going down from left to right there. So it starts at -1, and it decreases, it stops decreasing at +1. So the decreasing would be from -1 to +1. So it actually starts and stops. It doesn't have anything to do with infinity. Okay? All right, so that looks like a really similar one. Oh, I think it is this. I think it is the same one. I think I just accidentally have 2 slides for it. So if you want to, you can just say the decreasing. What was that? It was from here to there. So it's from -1 to +1. That's that section that we've broken into -1 to +1. And the increasing was negative infinity to -1 in union with 1 off to positive infinity. So those slides, one slide was the problem and the other slide was us doing the answer. So that's why it looks like that. Okay? All right, let me get one just in case. And then, okay, so again, there's 2 slides for this, and I didn't really mean for there to be. So the question of this is, all right, find the intervals over which the interval is increasing, decreasing, and constant. So don't worry about this. You actually don't need to write anything. This is just the question. Okay, so we've got 3 turning points. We'll label them in a second, and then we'll get our answer. So let's do our answer on the next slide. All right, because there's a little bit of room there. Okay, so we've got 3 turning points. -1, -2, so that's one section, if it helps break it into sections. 3, -2, so that's another section. And 5, 2, that's another section. So those are the turning points. Remember, all you care about is the x value. And then it starts on negative infinity, and it goes off into positive infinity. Okay, so this first section is decreasing because it's going down. So this first section is decreasing. So from negative infinity until this first turning point, which is at -1, it's decreasing. So negative infinity to -1 is decreasing. Okay, there's also another section that's decreasing, and that's this one, because it's also going down. So as long as they're going down from left to right, that's decreasing. So it starts at 5, and it goes off to the right forever. So that's positive infinity. All right. This section is what we would call constant. It stays the same. It's not going up or going down. So it is constant from -1 to +3. So -1 to +3. And then this last section is increasing because it's going up. It's rising from here to there. So from 3 to 5 is where it's going up. Okay, so there are a couple different ways you could look at it. You could take it one section at a time, or you could say, where are we all going down, where are we all going up, and so forth. Okay? So you could increase, decrease, or you could stay constant. Constant is less likely, but that is a part if it goes straight across, okay? And then the next lesson is going to talk about the end behavior, which is the new stuff that we're going to be working on, okay?